Hello, I'm Desiree Black, part of the team Practical Neurons. I will give an introduction to the project. Artificial intelligence is one of the newest and hottest research topics and is used in several industries, such as retail, wearable devices, and manufacturing. One of the main issues with artificial intelligence is that the data collected has a large model size. Deep neural networks, DNNs, have an even larger model size, which causes higher computational costs and denser layer connections. This also causes issues with computation and on-chip storage.
Hi, I'm James. I am working on the neural network and the quantization of the neural network. Here's some samples of the data that we're working on from the MNIST handwritten data set. Um, this data set is relatively easy to train on. Here I actually create the baseline model, which is 32 bits of precision. This one actually takes the weights from the 32-bit precision neural network and quantizes them and puts them into the exact same architecture so we can test the two different conditions of 32-bit precision versus 8-bit precision. Here we're training it, got up to 93.77%. Here are the raw weights. As you can see, they're long, very precise numbers. We quantize them into 8-bit numbers. The smallest value is 1 over 64, which is 2 to the negative 6, which is 0.015625. So you will never see a number larger or smaller than this. For the baseline, we got 92.61% testing accuracy. For the quantized version, we got 92.59. We've never seen anything lower than a 0.04% decrease in performance. So those are the results, and then we just save them to a text file. Thank you.
Hello everybody, this is David Perez. So the weights for the neural network have been written to a text file and uploaded to the FPGA. We have written Verilog to extract the train weights from the text file. We have configured a Verilog environment for hardware programming and to properly read values for the CSV file. In the upcoming semester, we will further implement and finish matrix multiplication and forward propagation operations.
Hi, so I'm going to explain to you the main two pieces of hardware that we need to implement in order to recognize the design onto an FPGA board. And the first piece of hardware to implement is just a simple memory system to store the previous layer's weighted values. And this needs to be have as much memory as the number of nodes in the first layer. And then the more challenging portion of hardware that we need to implement is a matrix multiplier. And the challenge comes because the matrices are of variable sizes, since each layer has a different amount of nodes per layer. So it's not just a matrix of size 2 or 3, it changes every time, so our algorithm to multiply the matrix has to be variable along with matrix size.